There's an entirely different strategy we can use for managing conditional logic that we didn't cover in coding 11, but I'd like to teach you now. It's not too complex and it's really useful for certain scenarios of branching conditions. I've pre-created a little bit of a menu here. This is a little start menu of a pretend game where maybe your first option is to choose a new game, second is to load, third is for a high score check, and the fourth option is to quit. We could technically, if we get a number from the user, say something like if number equals 1, then do this, else if number equals 2, do something else. So here maybe we just want to say now new game started, and number 2 would be here game loaded, and so on and so forth. We could build it with an if statement, but when we have specific values that we're looking for, it's often more clear and concise and helpful to use something different. We call these switch cases, and I'd like to show you how they work. So it begins by just writing the word switch and then putting an open and close bracket. And inside of this bracket, we are inserting the variable that we are going to be examining. In this case, it's the number the user input. Then I'm going to add some squiggly brackets just like we do with our if statement. So normally we're used to, for an if statement, saying if the number is compared to something like this. But in this case, we're not comparing it to anything yet. We're saying that this is the variable that is being examined. So what happens inside of the switch is that we have some different cases. And the case will have the value of the variable that we're examining. So what's the first value of this variable that's relevant to this menu? Well, it's number 1 we're looking for. So case 1, the case where the number that's input is 1. And I'm going to put a colon to say I need to do something after this. Now, I'm going to add a piece of content here that we'll explain in a sec, but we always for now want to add this break statement after our case and leave a space. I'm just going to go and Shift Tab to back up, and I'm going to add a second case with a break, a third case with a break, a fourth case with a break, and something called the default with a break. And I'll explain how this all works. So in case 1, the result is going to be new game started. In case 2, the result is going to be game loaded. In case 3, our result's going to be high scores. And I don't have a list, so we'll just pretend that the list will pop up here. And case 4 is quit. So how do we quit in Java? Well, here's a little kind of sneak peek of another piece of functionality or an explanation. System.exit. And then we have to give it a number. 0 is the close program exit status. Now, what is happening up here is that case 1 means if our number variable has the value of 1, do this. Case 2 means if our number variable has the value of 2, do this. And then 3, do that, and 4, do that. Default is basically saying the same as else, which means that this will cover anything that's not one of these cases being entered. And here I'll say you entered an invalid input. Let's run this and see how this works. So when I run my program, make this a little bit bigger here, the bottom. New game, load game, check high scores. I press 1, new game started. Okay, now once we get to our loop section, I could actually have this looping, but for now we'll just take a look at the conditions. 4 quits my program, and the last one I'll try here, let's type in the number 7, which is clearly outside the scope of this menu. You entered an invalid input. What if I put in a negative number? -1, an invalid input. Okay, this default actually managed to catch that as well. It's anything that was an input up here. So now in this scenario here, I have a different way of representing these different conditional situations. So the thing that I want us to be paying attention to here is this break statement. And what break does is it ends this whole conditional logic right when it hits this break statement. So if I don't include this, then it means that there's a possibility that other cases could be triggered if they're true. So the break really just means that after you do this, end this switch. Don't do anything else below it. sorry, my headphones rather than being turned off there. It's basically the equivalent of making this an else-if chain. Sorry, else-if chain. So the breaks break out of the conditional logic here. So if case 3 is triggered from the input, it'll print out high scores, and then break will mean this is all skipped, and it'll just exit out the bottom so that nothing else is run after it. And it's just a good coding habit to always enter this in. In this scenario, it actually would run just fine without them, but in future ones you use, it might actually not function properly. So it's a good habit to actually just remember to be using the break statements. And that's your switch. Let's take a look at one more really quickly here. Just in case that you want to work with a different type of data, technically, we could actually, with our scanner in here, get a string by just saying get next. And in this switch, maybe I'll have this be input. And now the input is a different type of data. So these numbers aren't going to work anymore because I'm expecting a string type variable to be input here. So technically, I could actually just make this a string for these numbers instead here, because I'm working with a string. The data type of the case check has to be the same as the data type of the input information. So I'm gonna leave all this the same here, but let me just run this through and check. And now I'm actually getting the string number 1, new game started. Cool. It all works just fine. And let's just try, I don't know, 3 this time. I didn't try that one before. High scores. So it works just the same. I have a different data type, which means I have to process the cases using that data type information. But otherwise, the logic all plays out just the same. Good luck using switch cases.